Jai Hind all. The topic for today's lecture is routing protocols in ad hoc network, and it comes under and it is covered under Unit 5 for the subject mobile computing. These are the contents which I am going to discuss with you. Routing, what is the meaning of routing and why we require the separate routing protocols for ad hoc network, what are the goals for the routing protocol. Then one of the case we are going to discuss specifically, that is the reactive routing protocol, which is also known by the name on-demand routing protocol, and the protocol trade-offs. So why we require the routing protocol? The purpose of routing is to find the best path between the source and the destination when the packet is being traveled over the network. In the case of the traditional network, routing is a relatively easy thing because routes can be uniquely identified based on the IP address. But in the case of the MANET, we are aware that the nodes which are forwarding the packet from to another destination, they are under the movement. They can come join the network and then they can go leave the network whenever they require. So the simple IP address based routing is not possible in the case of MANET because the topology is continually changing and the nodes make a route may move or shut down during the due to the low battery energy. So each node in MANET need to have the routing capabilities, and due to this we are having separate sets of routing protocol for the ad hoc network. So what are the goals of a routing protocol? The packet must move towards its destination. The number of hops or the path, it should be minimum. The delay should be minimum. Packet loss should also be minimum. Packet does not move around the network endlessly. That is, they should not enter into a loop, and it should decrease the routing related overhead. Routing related overhead should also be minimum. So why the routing in MANET is different? Because due to the host mobility, link failure or repair due to the mobility may have different characteristics than those due to other causes. Rate of link failure or repair may be high when the node they move fast. So new performance criteria, they are needed when we talk about the routing in MANET. That is the route stability despite mobility and the energy consumption. So whenever we talk about the routing protocol, these two performance metrics, they come into the picture. The routing protocols for the ad hoc network, they have been categorized basically into two. One is proactive set and another one is the reactive set of routing protocols. Proactive routing protocols, they are also known by the name table-driven routing protocol, and the reactive routing, they are also termed as on-demand routing protocol. In the case of the proactive, the routing tables, they are maintained in advance, whereas in the case of the reactive routing, the routing table, that is the route, they are created whenever there is a demand in the network. So first we are covering the proactive routing or the table-driven routing protocol. Each node maintains a table containing routing information to every other node in the network. When the network topology changes, then in that case, the node propagates updated message throughout the network in order to maintain a consistent and up-to-date view of the network. The proactive or the table-driven routing protocols, they are basically examples are DSDV, GSR, WRP, FSR, HSR, CGSR and so on. Out of these, only these two have been mentioned in your syllabus. In the case of the reactive routing or on-demand routing protocol, routes, they are created when they are required, not before that. Routes are valid till the destination is reachable or the route is no longer needed. Once the packet is delivered to the destination, then the routes, they are deleted. They are not valid. That is, when a new request is sent, that is send the packet from source to destination, then new route discovery would take place in the network. On-demand routing protocol, they have been, the examples are AODV, DSR, TORA, CBRP, ABR, SSR. Out of these 3 are in your syllabus. Trade-off, that is when we should go with them. Latency of route discovery, that is when we consider the reactive and when we consider the proactive routing protocol. Latency of route discovery, it says proactive protocols may have lower latency because the routes, they are maintained all the times. But in the case of the reactive protocols, although the latency is quite high, because a route from X to Y will be found only when X attempts to send some data to Y. So we need to see that whether the latency of route discovery, it can be up to what time, up to what delay we can bear with it. Overhead of route discovery or maintenance. Reactive protocols may have lower overhead since the routes, they are generated only when needed. In the case of the proactive, the overhead is high because we are keeping a routing table at all the nodes in the network. And since the network is ad hoc network, so the topology is continuously changing. So our continuous route updation is required. Which approach achieves a better trade-off depends on the traffic and mobility pattern. That is, if the traffic is very high, then in that case we will go with the proactive. If the nodes, they are coming and leaving the system continuously, then we will go with the reactive protocols in general. Another important factor is proactive protocols, always they maintain the routes, little or no delay for the route determination, consume bandwidth to keep the routes up to date, and maintain the routes which may never be used. Whereas in the case of the reactive protocol, lower overhead since the routes are determined on demand, significant delay in route determination due to this factor. It saves energy and bandwidth during inactivity. It can be bursty and it might create a congestion when the activity is very high. Good for light loads, collapse in large load. So which approach achieves a better trade-off? It again depends on traffic and mobility patterns. The specific case which we are going to discuss today is AODV protocol, that is your reactive protocol, ad hoc on demand distance vector routing protocol. It is given by Perkins in 1999. We have seen in the DSR that it includes the source route in packet headers, and it results large headers which sometimes degrade the performance, particularly when the data content of a packet are small. So AODV attempts to improve on DSR by maintaining the routing tables at the nodes so that data packets do not have to contain the routes. AODV retains desirable features of DSR, that routes are maintained only between nodes which need to communicate. Route request packets, they are a special kind of packet which is designated by RREQ, are forwarded in a manner similar to DSR. In the DSR, we have seen that we are having RREQ, RREP packet and RERR packet. Similar packets, they are also available with the AODV. When we require to discover a route, we send the packet RREQ. When there is some updation in the route, then we are having separate packet. When there is an error in the route, then we are having RERR packet. So when a node rebroadcast a route request, it set up a reverse path pointing towards the source. AODV assumes symmetric links. That is, AODV says that the link between the source and the destination is bidirectional in nature. When the intended destination receives a route request, it replies by sending a route reply, that is RREP packet. Route reply travels along the reverse path set up when the route request is forwarded. That is, if this is my source and this is my destination and the packet is going in a single hop, then in that case it will send a packet by RREQ and it will send a packet, that is RREP packet, and a reverse link is being established. How the route discovery is being done in AODV. Route discovery allow any host to dynamically discover a route to any other host in the network, whether directly reachable in single hop or through multiple hops. It uses the following steps. Source S, suppose we are having a source by the name S. It broadcasts a route request RREQ packet to all its intermediate neighbors. RREQ, what details RREQ contains? It contains the address of source and the destination D. It contains a request ID. Basically, it is being used to identify and discard a duplicate route request. Source and destination sequence number. Why we need them? To identify a new route from the old ones. Hop count. It keeps the track of number of hops the packet has made. It is initialized with 0. On receipt of RREQ, an intermediate node appends the source address and request ID in its local history. It will update its cache if RREQ is not a duplicate. If intermediate node's routing table contains a route record, let's suppose from S, the packet reach to a intermediary node A and it wants to communicate the destination node D. A contains the route to D. Then in that case, this node will reply back to S with the route information. So, if intermediate node's routing table contains a route record for the destination, a route reply RREP packet is sent to S. If not, it increment its hop count and rebroadcast the RREQ. A backward route towards the S is also created and a timer is started for it. If the timer expires, then in that case, entry would be deleted. When D receives the first RREQ packet, it sends back with a reply packet, that is RREP packet. Now what information RREP packet contains? It contains source address, destination address, hop count, which are copied from the RREQ packet. Destination sequence number is taken from its counter in memory. Lifetime controls how long the route is valid. This information is also required. On receipt of RREP, intermediate nodes on the way back create a backward route towards the D if following the conditions are met. That is, no route is to D is known a priori. The destination sequence number in RREP is greater than that in the routing table. That is, a new route has been discovered and the sequence numbers are equal, but the route is shorter. In this way, all the nodes in reverse route learns the route to D for free as a byproduct of this protocol. The intermediate nodes that got original RREQ but were not on the path, they discards the reverse route table entry. That is, they delete this entry from their cache. Now, how the route maintenance happen in AODV? Route maintenance monitor the operation of a route in use and informs for any routing errors. Following steps, they are used for the route discovery. For each entry in the routing table, every node maintains the list of its active neighbors. When next hop link in routing table entry breaks, a route error message, that is RERR packet, is broadcast to all active neighbors, which also updates destination sequence number. The incremented sequence number N is included in RERR and the route discovery method is again reinitiated by S for D. So, let's have a look on the example. Here we are having a node S source and this is our destination and this is the picture for the ad hoc network. Now, S will send the request packet to its intermediary, the nodes which are in its network. A backlink is established from these intermediary nodes to the source, and after this backlink, they forward the message to their intermediary neighbors. In the case of this is the neighbor, and for this node, this is the neighbor. Again, a backlink will establish, and further broadcasting will take place in this manner, and in the last, the packet would be RREQ packet would be received by the destination node D. Now what will happen? Once this link being established, D will send the RR reply packet to the source, and this is how intermediary updations will start taking place. Now here a forward route is being established, and the source is aware that the data packet, when it will send the data packet, it will send through this route, and they will delete the information from their local cache. This is another example. Here we are having a representer node that has received RREQ for D from S. So it will represent the transmission of RREQ. Dotted lines, they are showing the propagation of route request packet. These are the neighbors for S. So it will broadcast the RREQ to these node, and a reverse link would also being established here, and they will further broadcast to these node. Now C will discard when it receives a RREQ packet from E, because it has already received from S, and the same thing will happen with other nodes also. Node C receives the RREQ from G and H, but does not forward it again, because node C has already forwarded RREQ once. So this is how the reverse link, how the things being done in the AODV. Node D does not forward RREQ because node D is intended target of the RREQ. D comes to know that it is a target node, so it will not forward the packet to M. And also these nodes, they are not in the network, so they also don't receive the packets, RREQ packet. Now the route reply, the D will send the route reply to its node, the route which it needs to follow, D to J, J to F, then F to E, and E to S. An intermediate node, not the destination, they may also send a route reply. The only thing is that they should have the recent path information to determine whether the path known to an intermediate node is more recent. For this, destination sequence number, they came into picture. The likelihood that an intermediate node will send a route reply when using AODV is not as high as DSR. A new route request by node S for a destination is assigned a higher destination sequence number, and in that case, an intermediate node which knows a route but with a smaller sequence number, they cannot send the route reply. This is how the forward route is being set up, and when the S communicate, it will communicate through this path. This is how the data delivery is done in AODV. Now what will happen when there is a route error? When node X is unable to forward the packet P on link XY, it generates a RERR message. Node X increments the destination sequence number for D, which is cached at node X. The incremented sequence number N is included in RERR when node S, and it will broadcast it. Now the node S, that is a source, will receive the RERR, and it initiates a new route discovery for D using the destination sequence number, which is as large, which is sequence number at least as large as n. That is, it will assign a new sequence number more than n. So this is how the root error, whenever there is a root error, this is how the updation takes place in the ad hoc network with the AODV protocol. These are the references which I used, and this is all about the ad hoc protocol. So what we have seen in this lecture, we have seen why the routing protocol, they are required separately in the case of the ad hoc network. The types of the ad hoc network routing protocol, that is reactive and proactive. One require the things to be known in advance, and other says that whenever there is a requirement for the communication, only then the route would be discovered. Then we have seen which protocol is best in what situation, that is a trade-off of routing protocols. And we have discussed one of the routing protocol, that is AODV, in this lecture. Thank you and Jai Hind.